Hello, everybody. So today it's Andrew, and today I have a problem for you. It's to help you determine the molar mass of a gas. And so here's the problem. The problem is a sample of gas has a mass of 0.311 grams. Its volume is 0.225 liters at a temperature of 55 degrees Celsius and a pressure of 886 millimeters of mercury. Find its molar mass. So in order to start this problem off, what we want to do is kind of sort out what is happening here. What's happened is we first want to figure out what you've been given. So the problem, so we're going to list out the givens here. You have been given that you have a gas with a mass equal to 0.331 grams and a volume that is equal to 0.225 liters. That's a 2. Okay. The temperature given to you is in degrees Celsius of 55 degrees Celsius. And your pressure is equal to 886 millimeters of mercury. And the problem is asking you to now find your molar mass and if you don't remember that is, it is grams per mole. So now that we know what we've been given and we know we want to find the molar mass, it is time for us to strategize and make a conceptual plan. So our conceptual plan is to have, we have been given P, we were given volume, and we're given temperature. We need to somehow convert that to moles, N. And so we're thinking about problems that we have, or equations that we have, and we have the ideal gas law, which you guys may know as Pervnert, PV equals nRT. And so from that, we can use that to then convert from moles to then a mass in grams, which will then give us our molar mass. And so our molar mass, like we said earlier, is equal to our mass over our moles. N, M over N. Okay. Oops, sorry about that. Okay, now it is time for us to solve the problem. So, first of all, we know we need to find N from up here. And so we're going to take the PV equals nRT equation, and we are going to make that into N is equal to PV over RT. Okay. So now we have solved our ideal gas law for N. And before we substitute into the equation for N, which is our moles, we first need to convert the pressure that we've been given from back here, 886 millimeters of mercury. We need to convert that to atmospheres, and we need to convert our temperature into Kelvin. And so, in order to do that, we're going to take our pressure, which is equal to 886 millimeters of mercury. We're going to multiply that by our conversion factor of 1 atmosphere is equal to 760 millimeters of mercury. Oh, I drew that wrong. And what we're going to do is get our atmospheres. So our millimeters of mercury cancel out, and what we're left with is going to be atmospheres. So when we multiply 886 times divided by 760, we get 1.1658 atmospheres. And with proper sig figs, we're going to round it here at the 6 because we only have 2 sig figs here. Okay, now it is time for us to convert from temperature of Celsius to Kelvin. And we all know that the conversion from Celsius to Kelvin is Celsius plus 273 degrees will give us our K. So we have 55 degrees Celsius plus 273 degrees will give us 328 Kelvin. Okay. Now it's time for us to substitute into the equation and calculate N, which is the number of moles. And so how are we going to do that? So what we want to do is calculate for N. So now we have N is equal to PV over RT. And so we're going to insert our pressure that we calculated in atmospheres from up here. 1.1658. Remember to include the whole number. 1.1658. And then we're going to keep track of that sig fig right there. And we're going to multiply it by what we were given earlier, our volume of 0.225. Oh, I'm sorry, you can't see that. 0.225 liters. Remember to keep your units. And then we're going to use the R is our gas law constant. Sorry. Of 0.08206 liters times atmospheres all over mole times Kelvin. And we're going to multiply that by our temperature, which is 328 K from what we calculated earlier. So our kelvins here are going to cancel. Our atmospheres should cancel here, and our liters will cancel here. And then this will flip over because of, yeah. And so now what you're left with is 9.7454 times 10 to the negative third moles, because the moles are going to flip up. And then we're going to keep track of our sig figs by keeping that bad boy right there. Now, finally, we're going to use the number of moles N that we've just found and given the mass to find our molar mass. And so our molar mass, if you remember, our molar mass was simply equal to our mass over our moles. N. And so now we take what we just calculated. We're going to take first we're going to get our mass that was given at the beginning of 0.331 grams. So we'll put 0.331 grams is equal to our molar mass all over our moles, which we just calculated out to be 9.7454 times 10 to the negative third. 9.7454 times 10 to the negative third. mole. Keeping track of our sig figs, which when you calculate that out, should come up to giving you a molar mass. It's equal to 31.9 grams per mole. And we also just want to make sure, check that our units are correct, because our question was asking us to solve molar mass of a gas. And so molar mass, we know, is grams, as we saw earlier, is grams over moles. And so that is what we have here. Check your units. And going back to sig figs, we have 3 sig figs up here. And then we remember to keep this one here, and because we're doing division, we're going to only keep the 3 sig figs. And so your answer should come out to 31.9 grams per mole. Thank you. Have a good day.